Hi, and welcome to your first MLO for Math 2201 from CDOI. We're going to talk today about your first unit, which is Unit 4 in the course, or Chapter 3 in your textbook. We're going to start with Section 3.2 on the sine and cosine laws. So we're going to get into first. Now, the sine and cosine laws are things that we use to solve to find missing components of triangles. Very similar to what you did in grade 10. Only in grade 10 you use sine, cosine, tan ratios, along with your Pythagorean theorem. Those things are all well and good, but they don't work unless you have a right angle triangle. So we're going to learn how to do all that same kind of stuff for triangles that don't have right angles in them. Alrighty, so that's what makes this more interesting as such. We're going to limit ourselves to acute triangles though, so meaning we have to deal with triangles that have no angles bigger than 90 degrees. The rest of them work kind of the same, but there's a couple of catches, so we'll just keep it simple for this course because that's the way it's set up, so that we don't have to move on to big triangles. Okay, so we're going to talk about how do we sketch triangles given particular bits of information, and we're going to talk about how we identify some of the geometric patterns that allow us to use the first of our rules, which is called the sine law. Okay, so first of all, we're going to remember our labeling convention. When I label a triangle, it's very important that I label it consistently with sort of the pattern that we're supposed to use all the time for these things. So I've got a couple of examples here. The first one says I've got an angle A that's 33 degrees. So that's a pretty small angle. So let's call this one angle A at 33 degrees. Whoop, 33 degrees. And our labeling convention basically says that the side that's opposite to that angle has to be side A. So the rule for this stuff is opposites, opposites, opposites. So if angle A is down here directly across the triangle from it, has to be side A. So angle B is 84 degrees. That's pretty big, and this is a fairly big angle up here. So there's our 84 degrees that we have. And directly across the triangle from that one is going to have to be our side B. Now we don't know what that is, so we'll leave it out because we don't have the information. And then I guess the only side and angle that we have left are going to be angle C and side C. And notice that they will be opposite from each other as well. Okay, so one more example just to make sure we got that. We got a big angle to start with. Angle C is down here at 75 degrees. We don't know how big side C is, but what we do know is where it is. It has to be across the triangle there. A and B doesn't really matter, but we'll go based on size. I think this one looks a little bit bigger, so that's 12 meters. We'll call that A. And B would then have to be over here. That one's 10 meters. And so therefore that would make this angle A, and it would make this angle B over here. So we've got the same patterns crisscrossing our triangle. And that's very important to keep in mind because when we get into using these laws, we have to be consistent with that. Okay, so we're going to talk about the sine laws. So if we can't use sine, cosine, tan ratios, or Pythagorean theorem, what the heck can we use? Well, here we go. The sine law is what we start with. So first of all, let's label up our triangle. It doesn't really matter how we label it if there's nothing already given in terms of which is A, B, and C, as long as we're consistent so that opposites are all the same letter. Uppercase letters only for angles, lowercase only for sides. So if we take A divided by sine A as an example, we're going to see what we get. And we're going to try B divided by sine B and C divided by sine C. Now this might seem like a little hocus pocus at the moment, but the idea is we're going to see what happens if I take any side and I divide it by the sine ratio for its opposite angle. So if I take 7.8, which is side A, divide by the sine of 40 degrees, plug those numbers in my handy dandy calculator, I get about 12.1. Let's try B divided by sine of angle B. So that's going to be 12 divided by the sine of angle B is going to be for us sine of 84 degrees. And that works out to be again about 12.1. And then we're going to take C divided by sine of angle C, and that's going to be 10 divided by the sine of 56 degrees. And wow, look at that. We got 12.1. So what that means is no matter which pair of opposites I pick, as long as I use consistently a side and its opposite angle, the length divided by, so the length of the side divided by the sine of the opposite angle always gives us the same answer. And that allows us to write this fancy little equation down here that we call the sine law. So that's what the sine law looks like. So any side divided by the sine ratio for its opposite angle will give us the same answer. All right. So what the heck do we need to do with that? Or as we like to say sometimes, what does that have to do with the price of tea in China? All right, so on we go. We're going to look at the ideas behind the sine law. And all it says is that if I'm going to find a missing side, let's say I wanted to find out what side B was. Well, what I need to do is I need to know what its angle opposite it is, and then I have to have any other pair, be it C over sine C or A over sine A. So if I want to find a missing side, whichever one I'm looking for, I set it up like that, and I don't need to use all three parts of the equation. As long as I have a known pair, C over sine C, I'm in business. I can use the same kind of thing when I have my angles. I just rewrite my equation sort of upside down. So if I'm looking for sine of A, I want to find out what angle A is, I'll set it up as sine A over A, and if this is the one I'm looking for, I have to know that, I have to know side A, and I'd have to know an opposites pair with a sine B and a B, for example. Okay? So basically, it's kind of a crisscross pattern in a triangle. You have to know two things, and then you can figure out one thing from a pair if you know the other. So if I knew what B and B were, then if I knew one of the A's, I could find the other one. Okay? So that's how that works. Alrighty, the last sort of thing we want to look at here is a little quick summary of all that stuff that we talked about. So when we label a triangle, we recall that the opposite components must have the same letter. Lowercase letters for sides, uppercase letters for angles. And determine whether the sign, and if we're going to determine whether the sine law can be used, we have to use the particular pattern in the given triangle, which is that crisscross pattern across our triangle, okay? So I have to have a known pair and then one thing out of the other group, and I can find the other, all right? So if we have a known pair of opposites, and then the sine law can be used to determine a missing component of any other pair of opposites. Now the specifics about how we do that we're going to get into in our next session, but that's it. That's your introduction to the sine law. Examples to come.